The era of magic wording and generic personas is ending. These theatrical practices rely on a model guessing intent rather than executing requirements. The weak prompt trap begins with a simple, vague instruction, pasting a script and asking the model to make the code better without defining any boundaries. In production, that vagueness is dangerous. It leads to scope creep, rewriting functioning code, or inventing non-existent libraries. These failures break stable systems. Repeatable results require a process called context engineering. Context engineering is the assembly of a payload, a structured, boundary-driven implementation contract that defines the system's behavior. Reliability comes from treating the model as a rigid engineering compiler, a system that requires specific instructions to generate a predictable result. Building an implementation contract requires the same rigor as an architectural blueprint. The prompt must contain specific structural pillars that enforce stability. The first two pillars are mandatory: a clearly defined objective and a specific audience who will use the final output. Next is the source of truth. It forces the system to trust your data exclusively. Scope and protected areas act as negative boundaries, telling the AI what to ignore, keep intact, and not invent. Finally, acceptance criteria act as quality gates, verifying usability. This structure transforms the vague request into a set of strict commands. It preserves the existing code state, targets only specific functions, and requires validation that older components still work. An implementation contract eliminates guesswork. Every required action is explicitly defined, and every prohibited action is fenced off. The anatomy of the document is only half the process. The chronology of the workflow determines the final quality. A cardinal rule of this pipeline is the separation of research from generation. These two instructions must never occur in the same step. In the research starter phase, the AI is used solely to gather evidence, map out terminology, and identify assumptions. This collected research is then packaged into a generator input. This second, separate step uses the discovered facts to execute the actual work. Phase separation prevents output pollution. It ensures the final artifact is built on verified evidence rather than early-stage brainstorming. Scaling this rigor standardizes performance across entire engineering teams. High-reliability organizations use prompt generator design to bake these rules into UI systems. This moves the responsibility of structure from the human to the interface. Drop-downs and checkboxes automatically capture constraints and source materials, forcing compliance before generation begins. For operations teams, AI prompts become version-controlled, reusable templates. This systematization yields predictable, testable results. Mastering generative systems is a discipline of delivery. It requires the assembly of a complete, boundary-tested work package.